So, hi, my name is Eric Barnstead. I run the Azure Industrial IoT team at Microsoft. Microsoft has been a pioneer in leveraging OPC UA also in the cloud, and I want to give you a little introduction of exactly how that works. So, first of all, why is OPC UA becoming so popular also in the cloud? Well, it's very appropriate to use OPC UA as the standard modeling language for digital twins of assets that you may have on your shop floor. Of course, like Henning already mentioned in the previous presentation, it also achieves interoperability even with devices that don't have OPC UA built in via adapters. But the main reason for using OPC UA as the standard also in the cloud is actually its data modeling and security capabilities. OPC UA is by far the most secure industrial standard, at least that I am aware of. Its security can be extended as well and kept up to date with new security features that become available, and older ones that are no longer secure can be deprecated. But the data modeling capabilities is where it's all about, because when you're doing cloud analytics, you need to have a single data model for all your assets. It's a requirement. And many vendors just invent a data model and use that. But our customers are telling us they don't want vendor lock-in. They want a data model that is based on an international standard. And the best one out there is OPC UA. So because OPC UA's data modeling is now also getting standardized, so not only the way that data models are built is standardized, but also the data models itself. That work, you saw it in Henning's presentation, is done by the German Machine Builders Association, the VDMA. And that's super critical work, because with standardized data models, you can detect what kind of machines you have as you discover them on your shop floor. And you can build analytics pipelines and condition monitoring dashboards beforehand, before you see the machine for the first time. So it's super powerful, super important work, and we're glad that the VDMA is doing this work. So in general, the previous presentation, also Randy mentioned it, there are two different modes for OPC UA. Previously, there was only client server, and here is the representation of the ISA OC stack for OPC UA client server. There's nothing new here. It's been around for a long time, but what the OPC Foundation has done is extended that with PubSub. So rather than client server, you have a publish subscribe mechanism, as Randy mentioned, and it is used for cloud communication. So now you have a UA application in the cloud that receives OPC UA PubSub data, either in binary format or in JSON format, and you can use standard cloud protocols like MQTT or AMQP as the transport for those messages. So, very often we still get asked, what should I use, OPC UA or MQTT? And the answer is always yes, because you're actually using both. So fundamentally, this extension of OPC UA is a super critical piece for doing cloud communication. So this is what a normal cloud analytics pipeline looks like. On the left, you have the asset. Sometimes that's an aggregating asset, like an OPC UA aggregation server, or in fact, a industrial connectivity solution, like Henning mentioned, from folks like Softing or PTC, et cetera, et cetera. But overall, you have many different aggregating OPC UA servers on shop floors today. That aggregating OPC server is then connected to an edge gateway, like Henning mentioned, and that edge gateway usually converts a client server communication pattern to a PubSub communication pattern. And then you're sending PubSub messages to the cloud. There's usually a cloud gateway as the interface to the cloud. Then you have an analytics module of some description, which reads the data and makes some initial insight or creates some initial insights, and then you usually store the data in a time series database. That time series database can then later be queried by machine learning methods or machine learning application to do long-term predictions. And you can also obviously build dashboards for condition monitoring or OEE calculation or similar things based on queries to that time series database. Or in fact, you can create a function from your machine learning algorithm that then sends insights to that dashboard. The stream analytics piece can also directly interact with the dashboard, which is the functions arrow up front. And then the dashboard can have a user interface which allows the user to run queries and then later call methods directly on the device itself. So say you realize that your device is running a little hot and you might want to slow it down a little bit to prevent damage. Well, that can be implemented in the dashboard by calling a method. Usually it's first sent to the cloud gateway and then on to the edge gateway. And then the edge gateway can convert that method back into an OPC UA method call. And that is what the digital feedback loop is all about, where you're constantly improving your productivity because you get insights that have pre-canned actions associated with them that you then automatically execute. So you can also do it manually, of course, but the trick is to have a self-optimizing system where you no longer need to have manual user intervention. So this is kind of how things work in general. Now, obviously, PubSub doesn't allow you to configure the gateway. So what you can do is you can build that configuration methodology directly into your dashboard. So for example, Microsoft has built a component that allows you to browse the asset, the OPC UA information model, directly from the dashboard through methods, right? So the dashboard would send a browse method to the cloud gateway, which passes it on to the edge gateway, and then the edge gateway would do create a client server session with the asset, and then browse the asset's information model and send the result back up through the same mechanism. So that allows you to configure what you send to the cloud through PubSub and how often. Right. So this is a powerful mechanism that PubSub enables. However, it would be nice to have access to the information model upfront. It would also be nice to have access upfront, meaning before the asset is connected to the cloud. For example, to pre-build a dashboard, right? Like I mentioned before, the work from the VDMA is super critical there. Or it would be nice to be also able to interact with the asset when it's offline. For example, the asset might be an oil rig, which only is connected to the cloud a few hours a day. So to do that, we've decided that we will create a new joint working group in the OPC Foundation that we call UA for Cloud Library, and I'll talk a little bit about that in another session in more detail. But the idea is that we create an information model database in the cloud that is capable of storing OPC UA information models. The upload is probably going to be based on the node set 2 specification. Right now it only supports an XML encoding, but adding a JSON encoding is trivial. And then you can have those OPC UA information models in the cloud available to everyone. And then you can run queries against that model database. So what do you need to enable all this? Well, on the edge, you're going to need something that converts a client-server communication to a PubSub communication. Microsoft has built the OPC publisher for this. This is also what was used in the VDMA showcase that Henning mentioned in the previous discussion. All of these things here on this page are available open source on GitHub. Microsoft also offers pre-built Docker containers for them. They're in the Microsoft Container Registry, and they're obviously also linked in the Azure Marketplace, so you can find them there pre-built as well. The publisher, again, converts client-server technology to PubSub technology and sends PubSub telemetry to the cloud. This allows non-intrusive data collection, which is super critical, obviously, in the industrial space. And we've also built a sample app that is also available open source. The OPC Twin enables exactly the scenario that I mentioned in the previous slide. So it allows browsing of the OPC UA information model from the cloud. It allows command and control. You can execute OPC UA methods using the OPC Twin, and it has a simple REST-like interface such that it's an easy development paradigm that your IT cloud developer are used to. Again, we built a sample app, and it also actually discovers assets directly on the shop floor as long as they're OPC UA enabled. So obviously OPC UA supports discoverability through either a local server or in fact a global discovery server. OPC Twin can make use of that, or it can actually just scan the network. That's also a possibility. And then finally, we've built a component based on the global discovery server to do certificate management. So in OPC UA, in part 12 of specification, certificate management is handled. Certificate management is important for OPC UA because obviously you're going to need X509 certificates to enable secure communication with an OPC server, right? And almost exclusively that I know of, security is either turned off, which is still unfortunately the main scenario that I come across, or certificates are in fact enabled and security is enabled, but they use self-signed certificates. And using self-signed certificates is like trying to emigrate in the US with a passport that you've written yourself. So that's not going to work and is not really secure. So to get around self-signed certificates, you're going to need either a private certificate authority or a public one. And the global discovery server, part 12 of the OPC spec, handles how that thing works. And what Microsoft has done is we've contributed the global discovery server to the OPC Foundation. It's available open source on GitHub, but we've also actually built a service based on Azure Key Vault. That's why we call it OPC Vault. And it maps the global discovery server functionality into a service. Again, it's available open source on GitHub, and you should definitely use it and make your life easier. And you don't have to run around your shop floor copying self-signed certificates from one place to another. So then what does the actual stack look like? Where does all this fit? Well, usually on a cloud stack, you have infrastructure at the bottom. These are your normal things like a management portal, user authentication. In Azure, that's handled through Active Directory. You have your virtual machines, you have your network infrastructure, and that's it. On top of that, you usually have a layer which is called platform as a service, where you have managed services that scale. Sometimes they hyperscale, which means that you don't need to worry about the scale itself. It manages that for you. And those services are globally available, right? And that's another important feature. So that alone, lots of cloud vendors struggle with. You know, it is non-trivial to stand up a global available hyperscalable service and manage that thing. You know, there's a few cloud vendors that do that. On top of that, you then have your OPC UA interoperability layer, or your industrial IoT cloud platform. And that's where all those services that I just mentioned sit. And then some vendors also have a software as a solution, software as a service solution, which, you know, in the Azure world is called IoT Central. It is a fully managed application where you don't need to worry about deploying or managing or running anything at all. No service needs to be deployed for that. You just get a login and use it, and that's it. So on top of that, then you have the services for specific use cases, for example, for OE optimization or predictive maintenance, and then applications that use those services that run as the user interface. So Microsoft at least says we are a partner-driven company. We don't build solutions, our partners do, but they should run on our platform. So this is how it works at Microsoft. So then this is the overall architecture. There's a lot here, but you'll see the components that I just talked about mentioned, the OPC publisher, the OPC twin. Here is a discovery module that, you know, was previously part of the OPC twin. So this only handles discovery now of assets and registers them automatically. Here are the, you know, industrial connectivity adapters from, you know, Softing, Iconics, Copper Data, all of them. IoT Hub is our cloud gateway. And then here you have the industrial services that run in Docker on Kubernetes, which is a managed Kubernetes service. So you don't need to worry about managing that yourself. Here we have OPC Vault, again, which is based on Key Vault. It uses Key Vault under the covers, and so on. So these are basically the services that I mentioned. Your stream processing pipeline is here through Stream Analytics or Time Series Insights. Time Series Insights is also our time series database. The OPC registry here will eventually be extended to be the information model database. And then, of course, you also have machine learning, which is down here. And this is basically it. Then what can we do in terms of dashboards? Well, we built what we call the Connected Factory Solution Accelerator. It's a solution accelerator. Again, Microsoft doesn't build solutions. We enable them. You can find the solution accelerator on AzureITSolutions.com and on GitHub. It is also open source, and it's a starting point for a full solution. What we've implemented is things like OEE calculation. This has been around for a long time. So we released that thing about 3 years ago, and it's super popular, in fact. So, you know, we think that it's a good starting point for a solution. It also uses OPC UA security end to end. And to make sure that it actually is secure, we've threat modeled it and we penetration tested it by a third party. So these were all ex-NSA members that, you know, are kind of white hat hackers. And they did find a few things. We fixed them before we released Connected Factory. So we're pretty confident it's a secured solution. And then, of course, it also handles things like alarms and events. And as you can see, there's visualization. There's a hierarchy of production locations and the OPC UA servers. It actually comes with a simulation using real OPC servers. and those OPC UA servers are also in a hierarchy based on production lines and so on. So check it out. You can deploy it with relatively little cost into your Azure subscription to try it out. And this is it. That's the end of my presentation. That's the end of my part. Just questions, let me know.